Statistics is the study of how you collect, analyze, and draw conclusions from your data sets. So it is widely useful technique that you can use to bring future into focus and infer and answer key tons of questions in Python. So welcome back to the channel. Welcome to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. Today is day 43, if I'm not mistaken. So we are on our 7th course out of the 9 course in this whole learning journey. So the goal is to learn Python over the next 100 days. And we're actually following a curriculum on DataCamp, which is the Data Analyst in Python career track. And we're on the 7th course, which is Introduction to Statistics in Python. So we actually started this Introduction to Statistics in Python a couple of live streams behind or back ago. So we've looked at summing statistics where we learned how to use tools like explore summing statistics, including mean, median, and standard deviation, and learn how to accurately interpret them using this statistical analysis and technique method. So today we are looking at what is called random numbers and probability. We learn how to generate random numbers, measures, and chance using probability. We're also going to work with a real-world sales data set to calculate the probability of a salesperson being successful. So in this second chapter of this Introduction to Statistics course, we are looking at random numbers and probability. So we are on the second chapter. So if you want to start from Introduction to Statistics in Python, I encourage you to go back to a couple of live stream back where we looked at what statistics is, types of statistics, and also other kind of stuffs all about statistics. So without further delay, I'll just start sharing my screen. Then we get into the lesson. So if you're looking to learn data analysis in Python, definitely Power BI, SQL, we've covered previous live stream where we did something similar to this. I'll just start sharing my screen real quick. So we are introduction to statistics. I'll just click on continue. So we've covered a lot of lessons in Python, from Python variables, lists, tuple, or so many other Python knowledge that we've covered so far. So you can just go to the live stream tab on Excel Island and just check out all those Python lessons. So this was where we learned. This was where we stopped just one day ago. So the goal is to learn 1 hour daily over the next 100 days and see how far we can go. So we're on the second chapter of this Introduction to Statistics in Python course, which is random numbers and probability, where we are going to learn how to generate random samples and measures using probability. We also work with real-world data sets to calculate the probability of a salesperson being successful. And finally, you will use the binomial distribution to model events with binary outcomes. So this is what we want to learn in this chapter 2. I'll just put on my headset so we can start. Okay, just making sure my audio is working fine.
People talk about chance pretty frequently. Like, what are the chances of closing a sale, of rain tomorrow, or of winning a game? But how exactly do we measure chance? We can measure the chances of an event using probability. We can calculate the probability of some event by taking the number of ways the event can happen and dividing it by the total number of possible outcomes. For example, if we flip a coin, it can land on either heads or tails. To get the probability of the coin landing on heads, we divide the one way to get heads by the two possible outcomes, heads and tails. This gives us 1/2, or a 50% chance of getting heads. Probability is always between 0 and 100%. If the probability of something is 0, it's impossible. And if the probability of something is 100%, it will certainly happen. Let's look at a more complex scenario. There's a meeting coming up with a potential client, and we want to send someone from the sales team to the meeting. We'll put each person's name on a ticket in a box and pull one out randomly to decide who goes to the meeting. Brian's name gets pulled out. The probability of Brian being selected is 1 out of 4, or 25%. We can recreate this scenario in Python using the sample method. by default, it randomly samples one row from the data frame. However, if we run the same thing again, we may get a different row, since the sample method chooses randomly. If we want to show the team how we picked Brian, this won't work well. To ensure we get the same results when we run the script in front of the team, we'll set the random seed using np.random.seed. The seed is a number that Python's random number generator uses as a starting point. So if we orient it with a seed number, it will generate the same random value each time. The number itself doesn't matter. We could use 5, 139, or 3 million. The only thing that matters is that we use the same seed the next time we run the script. Now we, or one of the sales team members, can run this code over and over and get Brian every time. Now, there's another potential client who wants to meet at the same time, so we need to pick another salesperson. Brian has already been picked, and he can't be in 2 meetings at once, so we'll pick between the remaining 3. This is called sampling without replacement, since we aren't replacing the name we already pulled out. This time, Claire is picked, and the probability of this is 1 out of 3, or about 33%. To recreate this in Python, we can pass 2 into the sample method, which will give us 2 rows of the data frame. Now, let's say the 2 meetings are happening on different days, so the same person could attend both. In this scenario, we need to return Brian's name to the box after picking it. This is called sampling with replacement. Claire gets picked for the second meeting, but this time, the probability of picking her is 25%. To sample with replacement, set the replace argument to true, so names can appear more than once. If there were 5 meetings, all at different times, it's possible to pick some rows multiple times, since we're replacing them each time. Let's quickly talk about independence. 2 events are independent if the probability of the second event isn't affected by the outcome of the first event. For example, if we're sampling with replacement, the probability that Claire is picked second is 25%, no matter who gets picked first. In general, when sampling with replacement, each pick is independent. Similarly, events are considered dependent when the outcome of the first changes the probability of the second. If we sample without replacement, the probability that Claire is picked second depends on who gets picked first. If Claire is picked first, there's 0% probability that Claire will be picked second. If someone else is picked first, there's a 33% probability Claire will be picked second. In general, when sampling without replacement, each pick is dependent. Head over to the exercises.
Oh, that's interesting. Probability is kind of technical a little bit. So let's see what we can learn from here. So with or without replacements, we need to understand probability with replacements or without replacements. That's interesting. So it says in the video, you learned about 2 different ways of taking samples, with replacements and without replacements. Although it isn't always easy to tell which best fits various situations. It is important to correctly identify this so that any probabilities you report are accurate. In this exercise, you put your new knowledge to test and practice figuring this out. So for this scenario, decide whether it's sampling with replacement or sampling without replacement. Flipping a coin 3 times. Flipping a coin 3 times. Ooh, let's see. When you flip a coin 3 times, that is replacement. You can just pick it up and flip again. I'll just use that ideology. Rolling a die twice. Rolling a die twice. A die. Rolling it twice. No, let's see. Let's see. Rolling a die twice. Hmm. Hold up. Randomly picking 3 people to work on the weekend from a group of 20 people. Randomly picking 3 people to work on the weekend from a group of 20 people. There are 20 people. So probably that you pick 3 people randomly. Okay. So from a deck of cards, dealing 3 players, 7 cards each. How many deck is in the card? You need to know how many decks are in a card. I have no idea. I don't play cards. I don't know that. I don't know that. Randomly selecting 5 products from the assembly line to test for quality assurance. Randomly selecting 5 products. Okay, let's see. Oh, oh, I missed that. I missed a lot of this. So rolling the dice twice. So flip the coin 3 times because you have to pick the coin again and flip it again. But rolling the die twice, you have to pick it again. So without replace from a deck of cards, dealing 3 players, 7 cards each. Okay, you can't replace the cards. Randomly picking 3 people to work on the weekend from a group of 20. So you're not replacing those 3 people again. Then randomly selecting 5 products without replacement. Okay. I think I figured that out. So radical replacement judgment. Correctly identifying the type of sampling that needs to be used is key to calculating accurate probabilities. With replacement, everyone always has 5% chances of working on the weekend. Without replacement, the second pick has 4 over 19 chance. The third pick, okay, 3 over 18. Because okay, now I understand it better. If you're using this randomly picking 5 people, okay, from randomly picking 3 people to work on the weekend from a group of 20, if I pick one person, the group is now 19%, so that will be 4, 4 out of 19. The second pick will be 4 over 19. The third pick will be 3 over 19. Okay. How about from a deck of cards, dealing 3 players, 7 cards each? What if the cards are not up to 7 each? So randomly selecting 5 products from the assembly line to test for quality assurance. From the assembly line. But we don't know how many people on the assembly line. Okay, that's good. Let's see. So calculating probability. I think I have access to the data set here also. Let me just open this. We have this Amil deal sales here. So this data set will be provided under the link in the YouTube description. So you can download this and practice along with it. So this was the data set we used last for chapter 1. So let's create a new Jupyter notebook and see what we can do here with this. We're going to create a new notebook. So let's see. Let me name it probability chapter 2. So this should be here by now. You can see it's a chapter 2. So I'm just going to launch this my notebook. I'll just import these libraries. I'll just copy it here. So I want to read this my data set. We're using this Amil sales in this second instance. So I want to connect to this data set here. Amil deals.csv. Sales. So sales. If I run the code. So these are our data sets here. We have just over 100 rows of data and 6 columns. If I say dot head, so we have the products, the clients, the status, the amount, the number of users. So we don't even really know what information this data is giving us though. So we are just going to to guess. If I look at sales dot shape, so we just have over 100 rows of data and 6 columns. Now let's go back to our instructions. So calculating probabilities. Let's see how we can calculate probabilities now in Python. So you're in charge of the sales team, and it is time for performance reviews, starting with Amil. As part of the review, you want to randomly select a few of the deals that is worked on over the past year so that you can look at them more deeply. Before you start selecting deals, you first figure out what the chances are of selecting certain deals. So recall that the probability of an event can be calculated by ways events can happen, total number of possible outcomes. So both pandas and numpy as NP are loaded and Amil deals is available. So you have Amil deals here also, Amil as sales. So I'm going to make use of it in my local computer here. So it says count the number of deals Amil worked on for each product, type using .value count and store it in counts. So I'm going to store it in counts. So count is going to be count the number of deals Amil worked on for each product, type using .value count .value underscore counts. So we want to count the number of deals Amil worked on. So that it does value count. So I'm going to call on the data frame, which is this Amil. In this case, these are our sales data cells here. So we're going to be Amil deals, the data frame Amil deals dot open brackets. I'm going to use this curly brackets. Number of deals Amil worked on. So they have a column called deals here. We have products, clients, one amount, number of users. So definitely is all of Amil's products. So I'm just going to select the products column and count it. So I'm going to select the products column from there. Products. I'm trying to use double quotes. Come on. Oh, yep. Let's run the code and see. Can see the count, number of products. Can see it there. Let me just run the code in Jupyter Notebook so we can see what we are looking at. So instead of Amil deals, I'm going to say sales here. Sales. So you want to count the deals for each product. You can see the deals for each product. Let's run counts. Let's call on count and see. Ooh, you can see the number of counts here. Product C is 1. Let me see that. The length is 178. You can see it's still 178. We're just looking at the same number of record here. 170. Let's continue though. Let's submit and see. Ooh, we didn't get it. Did you call Amil deals dot value counts? We didn't even select the products. Okay. Let's see. I don't need to mention the products column. Let's do it like this and see. Oh, we are wrong. Okay, let's get help on this. Oh, My mistake was using double quotes there. Oh, I didn't wrap my data frame in. I didn't close it over there. That was my mistake. Okay. I wasn't getting the correct answer. Do you see it now? So it's not counting number of products for each what? Number of sales for each product. So that was the mistake I did there. Better. So you are seeing the number of counts for each what? For each. So for product B, it has 62 sales. For product D, 40 sales and so on. I can also wrap this in single quotes. Let's see it in single quotes. We still have same result. So either of the way it worked fine. So we see the number of deals for each product. You can see for each product, these are the number of sales it made for each product. So calculate the probability of selecting a deal from the different product types by dividing the count by the total number of deals that may work done. Save it as probability. So we have to know the total number of sales that may work done. Okay, how do we do that? Okay, the total. We have to sum up all of this. 62 plus 40 all the way down to the last number here. That is total number of deals you worked on. So you calculate the probability of selecting a deal from the different product types by dividing the count by the total number of deals. Dividing the count by total number of deals. Dividing the count. So I want to count. So I need to count each. So we have the count of each product, but we don't have the total number of products. So that will be sum. So we just say probability equals to count data frame, count. So the count for each product is this count for product B, product D. So we're now going to say count divided by the total number of counts. So that will now be count dot sum. So count dot sum is going to add everything for us. This whole number here, count dot sum is going to add it for us. So let's see if I do count dot sum. So you get 178. This is now 178. So if I run this line of code now, this is now the probability of getting. So if I call on this and say calculate probability of picking a deal from each product. So it's going to be count divided by what? Count dot sum. If I run this code, if I now call on props, so it's going to show me probability of picking each product. You can see this is 34%, 22%. This you can see the probability for each product being picked being picking a deal with each product. So that's interesting. Okay, we're getting the hang of it. So let's continue. Let's submit. Now, if you randomly select one of our meals deals, what is probability of that the deal will involve product C? Let's see product C here. Product C should be 84%. That'll be 84%. So, okay, so we nailed this there. Why is 84%? That 80.4%. Am I correct? 84% or 80.4%. Let's see here. This is 84%. Oh, it is 8.43, not 84%. 8.43%. This is 0 here. So if I move it 1, 2, 1, 2, that is 8.4. So perfect probability calculation. Now that you know what the chances are, it's time to start sampling. Okay, let's see. Let's what we want to learn in sampling. Oh, we've been learning for a couple of days now. Okay. D is 34%, 22%. Probability of product D is 22%, and so on and so forth like that. So let's see sampling deals. So in the previous exercise, you counted the deals and made work done. Now it's time to randomly pick 5 deals so that you can reach out to each customer and ask if they were satisfied with the service they received. You will try doing this both with and without replacements. Okay, with replacement, without replacements. So additionally, you want to make sure this is done randomly and that it can be reproduced in case you get asked how you choose the deals. So you will need to set the random seed before sampling from the deals. So both pandas as PD and numpy as MP are loaded and Amiru deals is available. Set a random seed to 24. Oh, okay, let's see that. So additionally, you want to make sure it is done randomly and that it can be reproduced in case you get asked how you chose the deals. You need to set the random seed before sampling from the deals. So what I want to do now is to randomly pick 5 deals so that you can reach out to each customer and ask if they were satisfied with the service they received. You will try doing this both with and without replacements. Okay. So let's set a random seed. That'll be Amir deals. Amir deals. No. So our random seed is going to be np dot random dot seed np dot random dot seed. So that'll be 24. I want to set that to 24. So I want to say take a sample of 5 deals without replacement and store them as sample without replacement. So I want to take a sample of 5 deals. So that would be Amil underscore deals dot sample. I'll just close and open brackets. Let's see if we get that. Oh, this is showing me just 5. Let's see it in action here too. So we set a random seed. So we asked to set the random seed to 24. Then from then, so you can say sample 5 deals without replacement. So that's going to be sales. Okay. Let's see sample without replacement. How many is going to show us? So we got 1 here also, 1 deal instead of 5. So let's see. So I'm missing something. You see, I did Amil deals dot sample sample, of course. Let's get help. So I need to specify my 5 here. Oh, so the 5 is going to be specified there. Let's run it again. Now it has randomly selected 5 samples. So this is going to be 5. Oh, I need to specify the number of samples I want. Okay, voila, you can see. What if I run it again? You can see the first one is 108, 138, 88. Am I still going to get the same results? Because I got 5 random samples. Okay, interesting. So this is without replacements. Okay, now let's continue. Now take a sample of 5 deals with replacement and save as sample with replacements. So it's going to be sample with replacements. We are going to set same random seed to 24. Then in our sample with replacements, make underscore deals dot sample. So instead of 5 samples, I'm going to say replacement replace will now be equals to 2. You can see now. This is with replacements. So let's see. Here also, you set a random seed before. Sample 5 Ds with replacements. So I'm going to mention replace. This is going to be sales. Sample with replacements, and voila, we have our 5. So we could just get, we probably will get same deal over and over. Let's see, this is 145. And 145 came up twice. Can you see it now? So let's run this again. And I run it again. Now it didn't come up. So that is with replacements. Interesting. Okay, let's continue. Let's submit the line of code. Now, what type of sampling is better to use for this situation? Hmm. How do I know that? Let's guess. For this situation, so the idea is not to pick, since you want to pick 5 words, you want to randomly pick 5 deals, so that you can reach out to each customer and ask if they were satisfied with the service they received. So you don't want to pick same customer twice and reach out to the same customer over and again. I just go without replacements. Spectacular sampling. So it's important to consider how you take a sample, since there is no one size fits for all way to sample, and this can have an effect on your results. I think I'll just go with that. That's fantastic. So let's continue. So let's look at discrete distribution, creating a probability of distribution. Okay, let's see what we can do here. Let's do something more all the way to this space. So let's learn all about discrete distributions. Okay, and what is it? So we just spend just 30 minutes on the live stream. Okay.
In this lesson, we'll take a deeper dive into probability and begin looking at probability distributions. Let's consider rolling a standard 6-sided die. There are 6 numbers, or 6 possible outcomes, and every number has 1/6, or about a 17% chance of being rolled. This is an example of a probability distribution. This is similar to the scenario from earlier, except we had names instead of numbers. Just like rolling a die, each outcome or name had an equal chance of being chosen. A probability distribution describes the probability of each possible outcome in a scenario. We can also talk about the expected value of a distribution, which is the mean of a distribution. We can calculate this by multiplying each value by its probability, 1/6 in this case, and summing. So the expected value of rolling a fair die is 3.5. We can visualize this using a bar plot, where each bar represents an outcome, and each bar's height represents the probability of that outcome. We can calculate probabilities of different outcomes by taking areas of the probability distribution. For example, what's the probability that our die roll is less than or equal to 2? To figure this out, we'll take the area of each bar representing an outcome of 2 or less. Each bar has a width of 1 and a height of 1/6, so the area of each bar is 1/6. We'll sum the areas for 1 and 2 to get a total probability of 1/3. Now let's say we have a die where the 2 got turned into a 3. This means that we now have a 0% chance of getting a 2 and a 33% chance of getting a 3. To calculate the expected value of this die, we now multiply 2 by 0, since it's impossible to get a 2, and 3 by its new probability, 1/3. This gives us an expected value that's slightly higher than the fair die. When we visualize these new probabilities, the bars are no longer even. With this die, what's the probability of getting something less than or equal to 2? There's a 1/6 probability of getting 1 and 0 probability of getting 2, which sums to 1/6. The probability distributions you've seen so far are both discrete probability distributions, since they represent situations with discrete outcomes. Recall from Chapter 1 that discrete variables can be thought of as counted variables. In the case of a die, we're counting dots, so we can't roll a 1.5 or 4.3. When all outcomes have the same probability, like a fair die, this is a special distribution called a discrete uniform distribution. Just like we sampled names from a box, we can do the same thing with probability distributions like the ones we've seen. Here's a data frame called die that represents a fair die, and its expected value is 3.5. We'll sample from it 10 times to simulate 10 rolls. Notice that we sample with replacement so that we're sampling from the same distribution every time. We can visualize the outcomes of the 10 rolls using a histogram, defining the bins we want using np.linspace. Notice that we have different numbers of 1s, 2s, 3s, and so on, since the sample was random, even though on each roll we had the same probability of rolling each number. The mean of our sample is 3.0, which isn't super close to the 3.5 we were expecting. If we roll the die 100 times, the distributions of the rolls looks a bit more even, and the mean is closer to 3.5. If we roll 1,000 times, it looks even more like the theoretical probability distribution, and the mean closely matches 3.5. This is called the law of large numbers, which is the idea that as the size of your sample increases, the sample mean will approach the theoretical mean. Time to solidify your knowledge of probability distributions.
Ooh, this probability distribution is kind of uh highly technical. Let's see what we can do here. Mm, I think we have to stop here. So we'll just continue from here on the next live stream and see what we can get from here. All right, so let's stop here for today and continue from there on the next live stream. All right, so that'll be the end of the live stream for today on probability and random sampling. So we're going to continue from probability distribution and just rewatch the lesson over again. So if you want to learn all about Python from scratch, do well to just go to the live stream tab on the channel, Excel Island on YouTube. Go to the live stream tab and start from doing one, or we got introduced to Python basics, variables, lists, tuples, and so on. And I'll see you on the next video on the channel, and I'll see you on the next live stream as we continue on probability distributions. Let's get back to work. Have a wonderful rest of the day.